Hi everyone, it's Mr. Sansak here, representing GridPulse. This is GridPulse, running live on the Streamlit, and this is running live on Streamlit, and it's a single-page simulation environment built on to show how an explainable AI system will actually operate inside a smart grid control system. As this is the system, and this is a functional prototype with the code ideas to believe, and here we go. uh, this is our grid topology. uh, this is live KPI, operational control, top operations suggestion. The page is divided into three control zones. One on the left, the simulation engine, and where to advance the time, choose a scenario, and in the middle the operator controls, where to inject or clear the fault on the specific substation, and on the right the live KPI, grid start, demand, supply, renewables, and active fault count. Below that you get interactive grid topology, and most importantly the ranked AI recommendation. Now uh, we are now applying scenario, and then after injecting fault, and let's start from a clean baseline. A normal grid operation, you can see the live KPIs. You can see the live KPIs, and shows a balanced state. Demand and supply power are matched. Demand and supply power are matched, and the renewable are contributing around 73%, and no faults. And what if this is now apply scenario? This is also the this is the normal one, and this is both demand and supply power are matched, renewable are contributing. And now for the fault one, applying scenario in advanced stick and inject for it is a fault one, and that grid topology is a live network access graph. Grid nodes are generation. There are generators G1 and G2. Here G1 and G2, and orange node are batteries. Here like there's B1 and B2. Blue nodes are station S1, S2, S, and here S2, S3, S4, and here the S1 through the S4, S1 through the that's the S1 fault, and S1 through the S4, and the purple nodes are demand zone. This Z7, Z8, Z1, Z2, Z3 similarly, and this is even in the normal operation, even in the and let's continue with our normal one, and clear fault, advanced one. In the normal one, normal condition, the AI is already working. It's flagged a medium priority, and recommendation, medium priority recommendation, and pre-weight dispatch battery supports before the next peak window. Why? Why? And because the forecast demand is rising while the stability margin is tightening, and because the ramp up and the lower the risk of energy shredding, and Crucially, it shows its work. The SAP driver tells us exactly which grid features are pushing this recommendation. That's TU4, TU1, and there are these are the topology weighted load signals driving the model's output. Uh, Now here is stick now Stick advances the simulation by one step, representing the minutes of the real grid operation. What's the history at the bottom of the start to build? As a tracking demand, this is a tracking demand, and here is that demand kilowatt and supplied kilowatt is just a simulation, and the tracking demand here is the demand in kilowatt, and maximizing line utilization and supplied over the line. This is what continuous AI monitoring looks like. Every tick, the model reevaluates and the grid states update its recommendation. And this is the same like the segmentation, and that's the anomaly and renewables here. And here is our live line flow from to G1 to S1. That's flow kilowatt, that's a sample data I have used. And we have been now using the fault one, applying the scenario, and this is fault one. And if we target this S2 as a fault target, injecting fault target, and now that's a fault target. And here the top operator suggestion gives the readout of around of faulted nodes. Why? That's around why active fault at S2, routing flexibility estimated, preserves service continuity on alternative substation path. As similarly, inspect isolated load zone Z3 and Z4. Isolated load zone. One or more zones have no healthy path to supply node. And similarly, this is our AI recommendation engine, and that's a fault injection. I have triggered the fault injection that's on the S2. And similarly, look at the topology, and the topology already says that the grid and if grid state also immediately flip to the state fault count 1. And what was the AI does, that's from the high priority to lower priority. And why fault at S2 has reduced the routing flexibility and impacting estimated impact, preserve services continuity on alternative path. And that's an alternative alternation path. This is not a rule. The system did not look for the S1 reroute. It computed this from the live topology using the graph routing modules and the anomaly detection together. And this is a second suggestion, that's inspected isolated loads, and that's Z3 and Z4. There is a second priority action in the inspected load zone, one or more, no healthy path. They code this, and the SHAP explains. Here is what the GridPulse simple alert. Every recommendation apply. That's a tau value that are the topology weighted load features. Tau is contributing the plus to 21.5, and similarly they don't have to trust the black box. They can see the exact features and their direction and their magnitude. And now we are going to that's what our problem statement was: fluctuating demand and renewable sources as for my homeland. Similarly, for this type of complexity, It is not completely ML control, but instead it's a human in the loop system. And even in the demand surges, the demand spikes, max utilization climbs towards the limit, and the AI flags a high priority dispatch condition. And this is the forecasting, optimization, routing, and this is the GridPulse is a network acts for simulation with the SHAP explainable into every single recommendation. No black box, no silent alerts. Every action is ranked, reasoned, and traceable. We built this for the Algo hackathon to prove that the explainable AI, real-time grid intelligence don't have to be the separate problem. They can be one system. The app is now live at this URL, that's gridpulse slash algo streamlight.app, and the full source is on the GitHub. And here, as the system architecture is simple, as a grid sensor, that's a live grid sensor, lightweight, and it forecasts LTM 24-hour model prediction, LP plus LG, and this optimizes and routes and detects and explains with SHA ranking confidence and outputs. And forecasting here, what it does is predicts 24-hour demands for green grid zone, and it ingests historical load, identifies demand spikes, and feed prediction. As before, we have this is a transformer slash automation model, and the linear it covers the optimization layer, that's around a bit mathematical, and that's graph routing layer, grid as a graph, network topology, anomaly detection, load spikes, equipment faults, cyber anomalies, data injection, and similarly many types of anomalies are also detected, and their alternatives are also kept to be found. And this is explainable AI. Every decision with reason, operator sees why an action is suggested, satisfy regulatory explainable requirement. The requirement recommendation is in ranked operator action, and this is a high zone and low zone. Similarly, this is a performance impact. It's from the sample data I have found, and the real-time data where it might make a similar type of prediction with this one. So the optimization and the other substation could get the required amount of current. What makes GridPulse different? Demand forecasting, standalone, this is integrated and real-time. Multi-objective system, partially, that's mostly, that's partially, and this is LP plus GA, all objectives are. Is this graph based routing? No, that's really have been found. And this is a Dijkstra plus minimum cost flow. Is this real time anomaly detection? No, that's typical tool are not real time anomaly, that's rule based. This is isolation forest or ML model. Explainable AI, black box, that's totally and cannot define why that's reasoned. And this is every decision is explained. Integrated policy, this is siloed tools, and this is a fully unified system. Future work, we can make the deep learning forecasting, upgrading LSTM to transformer based or the attention based models, reinforcement learning, and it can grow with the infinite reinforcement learning, digital twin integration, safe policy in virtual grid environment before live deployment, partner with the energy real world deployment, partner with the energy infrastructure to pilot grid on the live SCDA connected grid argument, and towards intelligent and explainable smart grids. Also, let's smile real time explainable